That's all right. Why not? What is the R in this one?
Oh, we just realized that because it's going up, so we didn't do that because it's above one. Because when you absolute value it, it'll be.
Did you guys agree? Did you see that too?
Yeah.
Like, and even if you're confused here, like the 5 became a 6. Isn't that bigger?
Yes.
So if it's bigger, it's, I mean, if it's 1, it would be 5, 5, 5, 5, 5, 5, 5, 1. If it was less than 1, the 5 should have become like a 4 something, 3 something, I don't know, something smaller. So the 5 is becoming a 6. Yeah, they're totally right. R is greater than 1. So we can actually say right away, I would say diverges, if you want to be super snazzy, aka the sum does not exist. What is the R?
It's negative 6 over 5.
Negative 6 over 5. 6 over 5. Because R equals negative 6 over 5 because, remember, to get to a next term, you multiply by R. So to find R, we have to take, now we could have done it here, but we would have had to take the latter term and say, who were you multiplied by? AKA divide or multiply by the reciprocal. Negative 36 over 125. And some of you were like, stop. 25 goes into 125 5 times. 6 goes into 36 6 times. Negative 6/5. But for others of you, you're like, why can't you just do it here? 6 over negative 5? Yeah. 6 over negative 5. Anyway, either way, R is equal to negative 6/5, which is, whoa, but that's not greater than 1. It's not. But what are we trying to look for greater than 1? R or absolute value R? Oh. So is the absolute value of negative 6/5 greater than 1? Yes. Is the magnitude of this number, aka ignoring the sign, greater than 1? Yes. And in our notes, didn't we say something like, oh, I guess we didn't say it explicitly. I'm sorry. Hold on. We did say something about absolute value of R is less than 1, which means R is in between 1 and negative 1. That's what that means. I'm sorry. I didn't say what this one meant. This one means that R is greater than or equal to 1 or less than or equal to negative 1. So the absolute value notation does work. And to be honest, it's actually probably the more practical one to carry on to, I don't know, maybe something like Calc BC. But anyway, coming back. Those are the ones to like carry on. That means divergent and that means convergent. But if you need to, if the absolute value is confusing, all that means is, hey, if the fraction, whether it's positive or negative, is lower than 1. Hey, if the fraction, whether it's positive or negative, or the number is greater than 1, regardless of the positive or negative. Bless you, that's what ends up happening. Hold on, what if one of your classmates was right, and what if the R was 5/6? You do? So what if we were, oh, that's not what I wanted. Awkward blob. Okay. What if it was something where we had a 6, and then we had a 5, and then we had a, no, not if it's 5/6. Then it'd be a 25 over 6, right? And then it would be a 120, oh, it would go the other direction. What if this was our problem? And what if our direction was to find the infinite sum of this guy? What's the formula? We couldn't stop. We couldn't say DNE because it wouldn't DNE. There's a couple different ways of doing it. You could do A1, 1 minus r to the n all over 1 minus r, and say, I'm going to infinity. I know. It's a really cool, like, calculus-y thing. If you write this down and be like, hey, look, I know calculus, they'd be like, whoa. Well, they might be like, oh, little baby, you're starting on it. But it's okay. It's still good. It's still good. It'd be calculus. But there's an or. Yeah. There's an or. No, good. No, Lauren was right. So you could write the really snap. Wait. Isn't it S sub n?
Yeah.
Oh, so you could just memorize one formula and learn calculus. Or you could just learn another formula and not have to worry about the calculus. Now, what's the calculus say? The calculus says if you go to plug in to this guy, and you can't plug in like I'm stopping at 10, I'm stopping at 12, I'm stopping at 100, because you're not. But what you can do is you can still plug in, hey, my first term is 6. 1 minus, you can still plug in negative 5, 6 to the n and say, okay, I'm not stopping. I get it. I'm not stopping, but I know there's an or. It's okay. I'll let you do the or, but hold on. In chapter 12, you won't be able to avoid it. Remember in our calculator the other day where I had you plug in 0.3 to higher and higher powers? And 0.3 to the 12th was 0.00000. And so my, just treat it like 0, got you the answer with so many decimal places. Now, 0.99 to the 12th was still like 0.7 or 0.3 or point something. Would have made a difference. But 0.99 to the 1,000th, finally was 0.000. What's going to happen to any fraction or any decimal that's less than 1 as you go to infinity? 0.0000000. It's going there. It might take it longer. It took 0.99 to the 1,000th power, and it took 0.3 to the 12th power. But it's going to 0.00000. Every single fraction less than 1. Every single ratio that will determine, or I should say, that will converge or end in a sum. So whenever we think of I'm going to infinity, this is always going to go, as long as it's legal, to 0. If I'm going to infinity with a ratio whose sum converges, you don't say d/any, it's actually going to work, you can always just make that 0. So you can memorize one formula, and you can say if I'm going to infinity, that goes to 0. Poof! But if that's not less than 1, it's not going to 0, which means it won't have a nice set, finite answer. But if it goes to 0, Lauren, what ends up happening anyway? No. Pause. Tell me what's left. 6 times 1 minus 0 would just be... What Joe's trying to show you is the A1. Exactly. Which is why I'm saying, no. It's exactly right. So what am I saying? If you know what's going to happen, if you know it converges, where can you jump straight to? Yeah. But I'm just showing you the calculus as to why. And some of you are a new one. You're like, I'd rather just stick with the one I have to make. 0. That's fine too. But either way, you do end up with a sub 1 over 1 minus... Oh, calculator. It's impossible. Can't do this. Yeah, you can, because can't you just make that 6 over 6? And what's 6 over 6 plus 5 over 6? 11 over 6. And how do I divide fractions? I multiply by the...
36 over 11.
Right? 6 over 6 minus a negative is a plus, so I get 11 over 6, and then divide by a fraction and multiply by the reciprocal, and I end up with 6 over 1, 36 11. Dun, 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 dun. Faster than you could have done it in your calculator. Well, I did it slower so you guys could keep up. But yes, I could have done it faster in my calculator. I could have done it faster by hand than you in your calculator. Man, I can't talk. So, can we get back to our notes? No, back to your notes. Not in the homework pile. I'm not going to let you, make you, etc. do this by yourself. Because some of you last night got to these ones. Wasn't it the end of homework? The repeating decimal. That's why we're here. Yeah, that's why we're here. Okay, so repeating decimal. A decimal that repeats. There's a pattern. There's a multiplication because it's in the geoseries section. Would this be, is this 0.31888888, or is that line in the wrong spot? Yeah, I know. Hold on. I think the line might be in the wrong spot. Number 82. Ah, the 1 and the 8. Because that's an awful long line just for 8, and it's like over a 0. It's awkward. Oh, no. The line got moved. Sometimes there are updates, and then it messes up all my formatting. Sorry, guys. Okay, so how would you write this decimal? Don't die. Whoa! You keep on adding on more and more digits and more. Wait, you keep on adding on, adding on. How could I make this an addition problem? Wouldn't it be 0.3 plus, and then next to it would be 018 plus 00018 plus 0000, I lost track, 18, and then not more zeros, 18?
Yep.
So the 0.3 is kind of his own little dude. We'll let him be his own little dude. But here, do we see a pattern?
Yes.
It's always a 18, but how many zeros are being added every time? So is R 1 over 100?
Oh.
10 squared, 10 to the negative 2. Wouldn't that move the decimal places 2 to the left? And then another 2 decimal places? Oh my goodness. Joe, which is why there's a parenthesis, and I said keep him separate, right? But you're saying multiply because I put the parenthesis in the wrong spot. So think about how to better word what you saw. And say, wait a minute, shouldn't it be 0.3 plus? Now it's better. Yeah, so I needed to move my parenthesis to a more proper location. Good. So who's my geoseries? Not the whole thing, just this part. What do you guys think? Is this going to converge or diverge? Converge. Oh, yeah, less than 1. I'm good. I'm golden. There's an infinite sum. Well, how do I figure out the infinite sum? Yeah. So a sub 1 would be 0.018 all over 1 minus 100th plus 0.3. Don't forget the 0.3. He's important. What am I doing? I'm doing the geo formula. I'm doing Lauren's version of just going straight to the long story short formula. A sub 1, first term, boop, all over 1 minus r. Plus m. But what do we, calculator? No. What do you mean, no? Well, can't I make this 3 tenths? And then can't I make this 18 tenths, hundredths, thousandths? And can't I multiply by 100 over 99? What? Think about it. Think about it. Come on. Who's 1? 100 hundredths. What's 100 hundredths minus 1 hundredth? 99 hundredths. Dividing by 99 hundredths is multiplying by 199ths. And I did 18 thousandths because of tenths, hundredths, thousandths, the place that it was in. Oh, could you do this by hand? No, those are huge. Stop! What's 100 and 1,000 reduced to be? 1 and 10. What's 18 and 99 reduced to be?
2 over 11.
9 goes in 2 times. Goes in 11 times. So I end. Is it that weird though? It's just not nice, but it's not impossible. Because, wait, couldn't I change this to be times 11 over 11? So I'd have 33 over 110, and then I'd have plus 2 over 110, and I would get 35 over 110. Oh, you can reduce by dividing top and bottom by 5, but hold on, I have some questions all around the room. But some of you guys might want to throw that decimal in your calculator and see if we got it right. What's the question that I've skipped over? Oh, I could have sworn I heard questions. You guys are okay? Or are we just complaining?
6 over. No, 7.
It was 3 over 10, but I multiplied by 11 to get common denominators. Because that one had an 11 and a 10, so I multiplied that one by 11 over 11. So that was my 33/11ths, and then 2 times 1 over 10 times 11, and then I put those two together. I divided by 5. 7 over 22. Is it 0.318181818, Matthew?
So how come you would add two zeros? I thought that you had 3 in the very beginning.
No. In the very beginning, I already have one. Because my initial term is 18, not hundredths, but thousandths. How? There's 3. 20 zeros. Got it.
When I first gave you, it was 0.318.
3 was in the tenths spot. 1/8 was in the hundredths and thousandths spot. I separated the 0.3. So wouldn't 0.3 0.3181818. You see it? And I had to separate that 0.3 because he wasn't a part of the pattern. So my geoseries was the repeating decimal part, not the other part, which is why he just stuck around until the end. Does that make sense? Okay. Was I right? So wait a minute. Anytime you see a repeating decimal, you can make it a fraction like this? No? Why not? Well, as long as the repeating, no. But hold on, you guys, I mean, this one's easy, right? You know that one, right? I mean, you have that one. How do you have that one down so well? Because you use it a lot, right? But couldn't you also say that it's going to be 3/10 all over 1 minus 1/10? How did I do that? Because isn't it 0.3 plus 0.03 plus 0.003? Every time it's just 1. Why is that cool? Because it could be 3/10 times 10 9ths. Like, well, I already had that one memorized. Okay. What if I was to do 0.1666? I would have to have the 1/10 be his own dude, but then couldn't I go ahead and have 6/100ths all over 1 minus 1/10? Why? Because it'd be 0.1 plus 0.06 plus 0.006 plus 0.00. I'm only adding 1 0 every time. This is one that you see fairly often, isn't it? You're like, it's fairly often. Couldn't I make that 6 over 100ths times 9/10, 10 9ths? And that would be a 1, and that would be a 10, and that would be a 2, and that would be a 3. So it'd be, common denominator, 3 over 3. So 3 plus 2 all over 30 is 5 over 30, or 1. So could we go from any repeating decimal backwards? That's kind of cool. Wait a minute, so what's... Ooh. Maybe some of you have this memorized and maybe you don't. I want you guys to take a second and think about what that one would be. Ready, set, go in your group. Not with your calculator. 0.1111111. Oh. Point T? Sorry, 0.1111111. If that ever shows up on your calculator, some of you, now, if you haven't memorized, don't give it away. Show me the math. But if this is also another one that you might see from time to time. There you go. Follow the 1/3 pattern. The 0.33333333. This one's super similar to that because it's 0.1111111. Who's your A1? Who's your R? Plug it in your little baby fraction. This one was a little tricky because it was like when you do the 1 and the 8, you needed 2 zeros for the next term. Always 1/10. Yeah. Did you guys figure out that R is 1/10? You only need to move 1 decimal every time? Good. You have a mathematical formula as long as you break it down right to let you take any repeating decimal to a fraction. Do you guys agree? Joe's already given answers out. But he waited a little bit on this one. Yeah. Were you guys able to show it? Do the same thing with 0.66666 to get it to be 2/3. You can do the same thing with any other repeating decimal. Joe?
I think it's like how I get it first, like without the calculations, because it's between 1/8 and 1/10.
One way.
So it has to be something that
But not many people have 1/8 memorized.
it's only
No, I know you do. But I'm thinking about the rest of the world, right? So not a lot of people have 1/8 memorized. But that is a good way because your brain was like, I think it's a special fraction. And what mine does actually, if you guys are curious, which I'm sure you're not, but if you're curious, I think about 9 goes into 10 one time. And then I would go ahead and get, that's what my brain does. And then, I mean, that's how my brain sees it. I'm like, oh yeah, of course it's 1/9 because 9 goes into 1, 10, one time, one time, one time, one time, one time. But the geoseries thing is cool too. Okay, anyway, long story short, didn't you guys have a homework? Whoop. Whoop, where's your homework? There he is. I was having too much fun with extra stuff. However, how much time do we have left? How many of you guys were able to do the repeating decimal one last night? Yeah, okay. Let's finish up the repeating decimal homework problem and bring it tomorrow so we can grade all the problems and go over all the questions. Sound good? Cool. Because not only did we go over the repeating decimal-y thing, which was hard, and the very, very end of homework that some of you were like, yeah, no. But we also reviewed what? Infinite sums. So some of you guys got stuck on infinite sums and repeating decimals at the end. We did practice on both of them. Why not just go back in right away, finish up that end of homework because some of you were like, question marks. Now pause. Guys, I hate taking off points. If you don't like a problem in homework, now, number 1, are you supposed to skip it because you don't like it or because you can't finish it, understand it? You know the answer. But coming back, let's say you need to skip something. You are totally stuck. I've tried. Does me looking at your paper and seeing missing numbers, like you go from 23 to 37 and there were 3 problems that were supposed to be there that aren't even shown, should I give you credit for that? So if I say something like missing random problems, it means that I figured out that you skipped around in homework and only did the ones you wanted to do, but made it look like you did it all. That's going to lose you points. Some of you guys are still not writing just quick detailed blurbs on your vocab or quick descriptions of, I don't know, I have your thingy open right here. What's something that you could have written for homework? Find the sum. It's 3 words and it doesn't lose you points. Find the sum and then put your problem. Some of you are still losing points for not writing directions, etc. Give me quick descriptions of vocab. Give me quick little blips of the section. Not for every single problem, but for every single section. Like, this is what I'm doing. And then there was one other thing. Oh, you get to the end of homework and you're tired and you're like, yeah, I'm stopping. Okay, that'll lose you points if you just randomly give me 5 problems in a row with question marks. But if you give me the problem details, if you show me the directions, if you write out the sigma, if you put in equals, if you just show me something like you at least read it, you understood it, and you're coming to class like, I have it right here, please help. As opposed to, it's totally blank, I have no clue what was supposed to be there, I just didn't want to do it. Do you guys see the difference that I have to read into what you're submitting? Does that make sense? Okay. I want to give you points. I hate taking away points, and it takes me more time because then I have to comment, then I have to post the comment and wait for the comment to post and then go put the grade in. And I love you all, but I don't like taking away points for multiple reasons. One is selfish and one is caring. So whichever one you want to care about me in, whether it's your grade or whether it's me personally, just tweak those couple things and get hundreds on every single homework. Does that sound good? And those of you that are skipping around and just I'm just going to hope she doesn't notice I skipped half the homework problems and it looks like I didn't. Come on, have some integrity. Sound good? Yeah. But does integrity mean like, okay, fine, I'll steal someone else's homework and just copy it down and not even think about it? That's not integrity either. But that's between you and God, not you and me. I won't necessarily see it, but I'm challenging you in that way as well. Done. Okay, coming back. That was a nice little life lesson. We need to start section 9.5. We need to start section 9.5. Ooh. Do you guys see a sequence? Do you guys see a series? Huh. Yes, we did skip 9.4. Yes, I do realize. And yes, it was on purpose. I know. But that means there's one less section on your test. Is that your question? 9.4 is a great section for higher, like college pure math courses that some of you will never see. So it's good. Inductive proofs, it's actually really good. But really, I have deemed it unnecessary for where we're headed in the time that we usually don't have. If for any random reason we have extra time at the end of the year, unlike every other year before you, we'll cover it. And that's what I say every year. And it never happens. Anyway, go team. We are skipping section 9.4, and some of you might not realize exactly where we are unless you look at our homework sheets and not just Google Classroom. We are at the end of chapter 9a. Not literally, we have to take a couple days on this section, but we are close to the end of chapter 9a. And our test on 9.1, 9.2, 9.3, and 9.5 is on Tuesday. It was supposed to be on Monday. And then I tweaked things for a couple reasons that we'll talk about tomorrow. And the test is now on Tuesday, which we all are thankful for anyway. It's a non-chapel day, and it's not the day after a weekend, but it's still coming. And do you have formulas in 9.2 and 9.3 and about to be 9.5 that need to be memorized? And do you have some things in your calculator you need to be able to do? Yes, they're both important. Okay? That's all we're going to talk about the test today. For right now, how do you raise a binomial to a power? The first one's easy. A plus b to the 0. Anything to the 0 except for 0 is 1. Huh. That's easy. A plus b to the 1. That's easy. Itself. But what do you have to do for the next one? Don't kill a puppy. Foil. No distributing. Foil. Go. You foil the way you need to foil. If it's writing a plus b times a plus b off to the side and first, outer, inner, lasting. Yes, I just made it a verb. We do anyway, right? Foiling. Go foil. So first, outer, inner, lasting. Go. Do it. And some of you, just a few, are like, I can foil in my head. Cool. Still, get me a trinomial. Trinomial? I thought FOIL was 4 things. The outer and the inner are like terms. The outer and the inner are like terms. Yes, because multiplication is commutative. These in alphabetical order, which is why instead of choosing the BA, I'll choose AB. There's 2 of them because they're like terms. Whew!
Oh, wait, so it's like that.
That's a good question. I know that you're used to going in descending powers, but if we choose a letter to go first, then we go descending with him. And A was 1, and then A was 0. He was gone. Does that make sense? And the B's just kind of happened how they happened. Would you go 1? Multiply this by that? No. Multiply that by that. It's a little bit easier. So, oh, but wait a minute. Do you guys remember polynomial multiplication? How? You just, everything has to go to everything else. Every term in one has to be multiplied by every other term in the other. So He'd have to rainbow effect to everybody. And he'd have to rainbow effect to everybody. Ready, set, go. You're going to have a lot of terms, but it's okay. You're going to have 6 terms in total and 3 pairs that combine. 2 pairs that combine. And remember, if it's BA squared or A squared B, they're still like terms. You can flippity-flop the order of multiplication, at least with these types of values. P.S. It should start with an A cubed. It should end with a B cubed. But there's some stuff in between. Oh, we're not multiplying? Combining? Guys, don't stress. Some of you are trying to do it in your heads. If you can't, there's no stress. Just do it the long way. And then combine the like terms, and then figure out what happens. Do the distributing. Write out all 6 of them, and then say, hey, are any of you alike? Let me combine you. Remember, if the order's switched, but as long as the powers are the same, you can combine. I'll do it. Matthew was confused. I was trying to help you. Is it a rough one today, guys? Most of us are awake. A few of us are tired. High school are going to bed at 10. This is like a round of applause. That's a good thing, though. That's a good thing, though. No, there is a student. Oh, when was it? 2 years ago? Trying to think who it was. There was someone who was in bed by like 9 every night, but she would also wake up really early to do homework.
That's scary.
Who was it? But that's what the doctors would say. Like, you need to figure out how much sleep your body needs and then give it that sleep. Otherwise, your life expectancy goes down.
Yeah. To me, it's a risk factor. If I can't finish my homework before I go to sleep, I'll just go to sleep first.
But it's hard. What do you choose? The immediate, what you're supposed to do right now, or the eventual? Most people go for the immediate and forget about the long term. It's dangerous. Adults do that too, probably even more than you guys do.
Yeah.
But they also have a lot more responsibilities weighing on them sometimes. So it's harder for them to make that choice. Well, because there's an A squared B. No, technically there's a 2A squared B, and then there's a BA squared. But remember, we can flip that order, and a 2 and a 1 will make a 3. Ah. How would you go one more? Joe's like, there's a pattern, and there totally is a pattern. We're about to see it. Because he was like, you can just go that. Yeah, that's called the binomial theorem. It's right here. Because if I was to ask you to go one more, some of you are like, you gotta be. It gets worse and worse and worse and worse. Except I am not going to write any multiplication. I'm going to show you what is going to happen because I know the future. Well, that's not necessarily true, but I do know the binomial theorem. Whoo! What's the pattern? As A goes, wait, pause. As A goes down from what? The highest power is going to be, what the entire binomial is raised to. As A starts at the highest power and counts down to eventually A to the 0, what does B do? B starts at the lowest, or do you guys notice that 4 plus B to the 0, 3 plus 1, 2 plus 2, 1 plus 3, don't they all add up to powers of 4? That's kind of cool. So as A counts down, B counts up. But wait a minute, this is to the 4th power. How many terms are there going to be?
5.
The 3rd power had,
4.
the 2nd power had, the 1st power had, the 0th power had. Oh, okay. So there's patterns as far as the powers of the first. There's patterns as far as the power of the second. There's patterns as far as being able to double check that you've done it correctly. But there's also patterns for the numbers in front. What was Joe just saying a second ago? A triangle? It's a 1. It's a 1, 1. It's a 1, 2, 1. It's a 1, 3, 3, 1. It's a 1, 4, 6, 4, 1. This is called Pascal's. We actually have a whole little page on it in a couple that we might not take a lot of time on if you guys already see it today and have already seen it. But how does this pattern work? What's on the left-hand side every single time? What's on the right-hand side every single time? 1. But where do the middle ones come from? It's kind of like Fibonacci-ish. Yeah, Joe's saying there's Fibonacci in here. There are patterns in here for sure. There are other patterns like, ready? First power, second power, third power, fourth power. Ooh. Oh, there's tons of patterns. So you guys see that weird thing that's been on my wall the whole year? The triangles? Did you see that they're triangles within triangles within triangles within triangles within triangles? We can think about it as a fractal, but it's also Sierpinski's triangle. And also, if you keep expanding Pascal's and if you highlight certain patterns that exist, Sierpinski's actually comes from Pascal's, or Pascal's comes from Sierpinski's. Anyway, but all that to say, there's a lot of cool patterns in Pascal's, but where we're applying it now to is called the binomial theorem. And the binomial theorem says, now careful, it gets harder than just A's and B's. X's and Y's, well, sure, that's fine. But it could also be 2x plus 3y. It could also be 5x squared minus 1. It could also be something in the A spot, something in the B spot. Whenever you are raising an x plus y to the n, or if you want, you can go ahead and say an a plus b to the n. That's also fine as well. We can always say that the first term is going to start at the highest power and count down, count down, count down, until eventually there's only one and then there's none. The second guy is going to start not there. Remember, like with sequences in series, if you go from 1 to n, there's n terms. If you go from 0 to n, there's n plus 1 terms. So y starts at the 0 and counts up until eventually he's only 1 away from his highest, and then he's at his highest. But if you guys notice, Pascal's triangle is only as good as how many rows you do. What if I was to say something like, can you go ahead and give me the 10th power expansion of 2x squared minus 5y squared? No. Well, to do the 10th row, wouldn't you have to do like all the 9 rows before it? No. That's like the recursive formula for sequences in series. There's another way to jump to the coefficient. Do you guys notice those are variables, those are variables? This dude is the coefficient. You can jump to places in Pascal's triangle without having to do the whole triangle. Now, there are times it's going to be nice to do the triangle and do like, oh, hey, it's a cube. Cool, 1, 3, 3, 1. There are times it's going to be helpful when n is pretty small. But if n is pretty big to the 10th power, to the 15th power, to the 8th power even, you're like, I don't know if I want to go that high. And as the numbers get bigger, our mental math, there are more places where you can make mistakes. And so this whole like, hey, you can jump to a place in Pascal's could be cool. But the way that you jump there, it's called NCR. That's how I'm going to read it. When we learn more about probability, there's another meaning to it, another use for it. But for right now, factorials have come back. But that's okay. We know what factorials are, right? If this was 10, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. True? So we can go ahead and take n factorial over n minus r factorial, r factorial. Check it. Who is n? Who is r? R is the power of y, and n is the power of the binomial. So that's how we can find the different pieces to plug in. So for instance, if I was going to have you do something that Honors did when we were here, I don't know, a couple weeks ago, and if I was to have you just start going with Pascal's triangle and go as many rows as you can over the next like 2 minutes, which I'm not going to. And if I was to have you go and go and go and go and go, and if you were to go and go, well, we can do it all together as a class. We can go pretty fast, right? I already did some. Okay, can you guys help me out? So what would be next? Oh, it's a 4, huh? I heard you guys in the wrong order. Uh-oh, which one's right? Okay, what if I was to, like, go down lots and lots and lots and lots of rows and be like, I don't know, did I get off? How could you check? Well, you could check by saying, okay, this guy should fit the NCR spot such that, wait a minute, what power is this row? It's the 8th power. So this is technically A plus B to the 8th row. So I could say, okay, this is supposed to be 8C. R is the power of the B. Doesn't it start off with B to the 0? And then to the 1, 2, 3, or B to the 8th, 7th, 6th, 5th, 4th? How would I? Well, it'd be 8 factorial all over 8 minus 4 factorial times 4 factorial. Guys, don't we remember that this is 4 factorial times 5 times 6 times 7 times 8? And then this 4 factorial, those go away. 2 and 4 takes away 8. 3 takes away 6. I have 2 and 10 and 7. How'd I do? How'd we do? Oh. But could it be nice if they were asking us for something like a very specific term? Do you want to go to the 20th row of Pascal's? They're only asking me for one term. Maybe I should use something like the formula in order to be able to figure out now, what's the thing I'd have to, Emma, Lauren, hi, shh. The 5th degree of A. What? What would make A to the 5th degree? What must R be to have that work out? Oh, so it'd be 20, C, 15, A to the 5. And if A is to the 5 and the whole term is, or the whole power is 20, what must B be? To the 15. Could I plug that in a formula and solve? Without having to do Pascal's to the 20th row and then count over to the 5th degree? And wouldn't it have taken a long time to count over the 5th degree anyway, because you start at the 20th and you have to go all the way down to the 0th? Ugh, that would have taken forever. But in this case, all I have to do is go ahead and do 20 factorial all over 5 factorial, 15 factorial. Ugh, is that disgusting? Yeah, can't we take away 15? And so we end up with 1, 2, 3, 4, 5. And then we have, well, the 15's gone, so 16, 17, 18, 19. Would that have been a lot of mental math that we would have had to do in Pascal's anyway, and it would have been a huge number? Do you guys know there's a really cool place in your calculator, maybe under math? You're all curious about how to use your calculator that has an NCR? Bye. We'll finish this section tomorrow, but be ready because we'll have puzzles. And the binomial theorem will be the key to solving them. Bye, guys. It's meant to be today.